So we enter our shared folder there. Then my lecture for today is here. So you've got previous abstracts and the previous lectures are here. So the first one was this one. The second one is this one. The one you're looking at today is this one here. So you right click, you come here on open with, and you'll find this particular one here, Google Collaboratory, which is what we're going to use. So this particular platform, Google Collaboratory, as the name suggests, allows you to work with other people as long as you've shared the folder. So you can type in your code, your friends can see if you share the folder, you share the file, and you'll be able to work with other people. So you can develop your computer codes, not just alone, but you can develop them with other people together. So you can share stuff like that. The next bit, of course, since we are using cloud computing resources, we have to click on connect here. So when you click on connect, Google is going to allocate us RAM and disk space for us to use for this particular exercise which we're doing here. So once the connection is done in a few seconds, then I'll proceed. So you can see there's stuff happening there.
So trying
Yes.
to join, I don't know if there is
Oh, okay. Let me admit you. All right. Okay. So for this morning, the title is strings.
So can
And these are our objectives for this particular morning. We want to see how to create a string. How do you access a character from a string once you have created it? How do you access multiple characters from a string? How do you find the length or the size of a string? How do you check if a particular string is in that particular string, that's membership? How do you change the casing for a string, for example, uppercase, lowercase? And how do you combine strings?
it's okay, I think.
All right. How do you combine strings? How do you remove white spaces from strings? White spaces are basically some non-printable characters which computers use. How do you strip off white spaces? How do you format a string? How do you set the precision of numbers you're printing out? For example, we're going to look at pi. Pi has got so many digits, so how do you set the number of decimal places you can print pi to? And also this other bit of how do you access values by index. So we will start with what a string is. Basically, strings are very, very common, and basically we can define strings as just text. So basically it's a collection of texts or characters which you have put in matching single quotation marks or double quotation marks. So when creating a string and you choose how to create a string, you have to make sure that the quotation marks match, whether it's a single or double in this particular case. So let's start with the process of creating our strings. So the string we want to create in this particular case, of course, we all know this book, which is one of our best books, Principles of Physics. So I'm going to create a string which contains the text Principles of Physics, and this particular string, I'm going to assign it to a variable book, which is that. So basically, this equal sign is an assignment operator, so it takes whatever string we have this side, and this string is going to be stored in the variable book. So I'll click on run there. Then after that, I'll make a printout of the variable book, and you see that we have managed to store this title of our book, Principles of Physics, in this variable book, and we make a printout. Then you can check what kind of data is actually in this variable book, and you use the type function. So you there's a built-in function called type. You give it the name of the variable, and if you click on run, it's going to tell you to say what you have in your variable is a string. So basically, str is abbreviation for string. I'll create another string. In this particular case, this is going to be, so in the first one, as you can see, I used double quotes. In the second one, I'm going to use single quotes, and the name of the string in this particular case is hello world. Then I'll save it in greetings, and I can make a printout of greetings. So you say hello world there, and I can check what the type is. It tells me that's a string. you are not restricted to only a few combinations of words. You can actually have a sentence, or you can actually have a paragraph, or basically a whole page or a whole book, if you can do that, and you can save that in a variable as long as everything in this particular case is in quotation marks. So I create this text string. Python is one of the most famous programming languages. Then I save that in the variable text. Then I print out text, and I check the type. In this particular case here, you can see that it's string. So
Question.
yes,
So it doesn't double quotes or single quotes doesn't matter.
yes, either double quotes or single quotes is fine. Yes, they have. The only thing is that the double quotes or single quotes have to match. Otherwise, if they're not matching, then there's going to be a problem. So now that you have created our strings, we can access a single character, or you can access multiple characters from this particular string. If you want to access a single character from a string, you need to type out the name of the string, then followed by some square brackets, and inside the square brackets you indicate the index of the string of the character you want to actually access. So in this particular point, I'll print out again our string book, which is that. So I want to access, and our indices start from 0 with Python. So Python is a zero-based index language. So indices start from 0 and they go all the way. So so with 0 here, I'm simply saying I want to access the first character in this particular string, which is a P. So if I say I display book, then square brackets 0 there, I'm going to access the P, which is what I access there. If I want to access the fifth character, in this particular case, the fifth character is going to have an index 4, since the index is going to be 1 less than the whatever it is you're looking for. So I'll say book, then I put a 4 there. So I'll access the C. Then of course, if I want to access the last character in our string, I'll use a negative index, -1. So you can use positive indices like this. You start from 0, then you go like that, or you can start from the end here. If you're starting from the end here, you start with -1, then -2, like that. So you'll be moving from right to left this way. So if I give an index of -1, it basically means that I'm trying to access the last character in our string, which is ace in this particular case. And if I do that, that's what I get, ace. So now that you have accessed these characters, and you can see what I'm getting are actually things with quotation marks, single quotation marks there. So basically, these are also strings. If I access a single character from a string, what I get back is also a string. So with these strings which I'm getting, I can actually save them in another variable. For example, the last character which I accessed here, which is ace, I can save this particular character I've accessed. I can save it in a variable called letter. So if I do that, so this bit is going to access, this part is going to give me access to the S, then I'll save it in a variable letter, then I print out the letter, that's the S. Then if I check what letter is, Python tells me that it is also a string. So it doesn't really matter whether your collection of characters is simply one character, or it's a few words with some spaces, or it's a lot of words like in the case of a sentence, they still qualify as strings. So basically, that's how you access a single character from a string. However, it's also possible that you might want to access multiple characters from a string, and to access multiple characters from a string, what we use is actually what's referred to as a slice. So with the slice, what you do is you start out with the name of the string, then you followed by square brackets. Then inside the square brackets, you're going to put a slice, which is going to basically state where you want to start from, the index you want to start with, up to but not including the last index. So you start index up to but excluding your end index, and you're going to see how that works. So a slice is denoted by, as we're going to see, by colon. So I'll print out the principles of physics in this particular case. Then I want to access this particular series of characters, the characters which make up the word physics. So the start index for the P here is 14. So as you can see, the slice is denoted by a colon, but I have excluded the last, which is -1. If I put -1, what I'm saying is start from the P, go up to but exclude the last index, which is going to be S, and if we do that, we will not be able to have access to this particular S there. So if you omit the last index, if you omit the end, so it's going to start from 14 and get everything up to the end of the string. So in this particular way, if you do that, what you get is physics. If I put -1 there, as you're going to see, the S at the end is going to be omitted from this particular selection. So we don't include an end index. If you don't include an end index, then it goes all the way up to the end, and you'll be able to extract the physics from this particular text, principles of physics, like that.
Question.
Yes.
Is there a way of, because I see it is laborious to just start counting until you are on 14. Is there a way you just do by the letter, then you just slice that one?
If you do by the letter,
Because 14, what about if you have a very long string? It's a lot of way counting. And
there are other tools which come with this particular bit. So in this particular case, I'm just looking at just small pieces of text where you can actually quickly count. Yeah. So as you can see, this is a string. It has got quotation marks. So you can save it in a variable called subject. So this bit gives us the physics. Then this is an assignment. So we assign this particular value, which corresponds to this bit, into the variable physics. That variable subject. Then if I print out the subject, what I get is physics. Then if I check what kind of data I have in subject, you see that I have a string. So that's basically how you access either a single character from a string, or you access multiple characters from a string with Python. Once you have your strings, you can also find out the size of your strings using a function called length. This function comes built in Python, so you don't have to do anything much apart from just using it. So how do you do that? So you type out length, you give the length function the name of the string or the variable which contains the string, and if you do that, it's going to tell you that book has got 21 characters. If you give it greetings, it's going to tell you that greetings is made up of 12 characters. If you give it text, it's going to tell you that text is made up of 55 characters. If you give it letter, it's going to give you that letter is simply 1 character. If you give it subject, it's going to tell you that subject is made up of 7 characters. In this particular case, length counts everything. It counts spaces, it counts dots, everything. So even spaces are counted as characters. So it's not that there is some, if you look at our principles of physics, where this bit here, as you can see, that's a space. That's 1 character. Then here also, there, that's 1 character there. So even spaces are counted as characters like that. Okay, so that's how you do your counting. You can also check if a particular string is in a longer string. So in this particular case, remember we have got subject, which is physics, right? And we have got so we've got a string subject, and we have got book, which is principles of physics. So with this bit here, what I'm trying to do here, I'm saying subject in book. I'm trying to check if the value stored in subject, which is physics, is in the value stored in book, which is principles of physics. We know that principles of physics contains the text physics. So in this particular case, we are going to get a true. However, if you remember text, which is physics, Python is one of the most famous programming languages. In that particular sentence, there is no physics there. So if I say subject in text, in this particular case, I'm going to get a false. So basically, this is how you can check quickly. If you've got a small text, you can check if this particular text is in the other text. You can also use a not. You can say subject not in text. Now, these ones, in and not, as you can see, their colors are different. So these are keywords. These in and not have got special meaning in Python. And your variables, as you can see, are basically black. Your subject is black, your text is black. So in this particular case, if I want to check if subject is not in text, I get it true because the physics is not in our thing text. If I print out, if I make a printout of texts, say print text, if you've forgotten what it looks like, then I run this, you see this is what we have in text. Python is one of the most famous programming languages. So the subject, which is physics, does not exist in this particular text. Okay, so I'll delete that. Okay. When it comes to modifying characters which are in a string, well, it turns out that strings, as much as they're a collection of these characters, it turns out that you can't modify a character in a string. You can access the position, yes, but that position cannot be modified. You can't also, once you have created a string, you cannot add anything to a string. The only thing you can do is literally change the whole thing, whatever is stored in a particular string. So in this way, strings are immutable. They cannot be changed. You can't modify a string. You can't modify a particular character at a particular position, or the string itself, you can't modify it. The only thing you can do is simply try to change the whole thing. For example, we have our string subject. If I print that, so this is what we have here. This is physics. I can access the first character in physics, which is P. So I say subject, square brackets, 0 there. So I access the P like that. Then I access the P. But if I try to change the P to C, like we have seen, subject, then square brackets 0, then I try to assign this particular position. I try to assign it a new character so that I change from P to C. If I try to do this, Python refuses. It tells you to say that a string object does not support item assignment. So you can't modify a string once you have created it. The other thing is, yes.
So you have to rewrite
Sorry?
You have to rewrite.
You have to write the string, yes.
So if you made a mistake.
Yes, you have to basically rewrite the string. You also are not allowed to delete. So you can't modify, you can't delete a character which is already in a string. For example, remember this bit, this whole thing here, subject, square brackets, -1, this refers to the S in our physics. So if I try to delete the S, in this particular case, using our function delete, because that's what we use for deleting, it's a, do that, then you get a type error function which tells you that say that string object does not support item deletion. So strings are also a data structure, because remember what we did the last 2 weeks, we have been looking at these different data structures. Strings are like a list, except in place of the square brackets and the tuple bit, what you have are quotation marks. So the beginning and end of a string is denoted by quotation marks. So they are kind of a data structure, but for text. And they have this property whereby you can't do the modification. As you can recall, the people who have been attending, what I'm going through is basically similar to what you've been doing the past 2 weeks.
Yeah. Isn't concatenation not a deletion?
Concatenation is simply combining.
Oh, no.
You're combining.
Is that not modification?
No. So what happens when you're doing concatenation is that Python makes copies of what you're adding up, and it creates a new thing. But the actual copies themselves, the actual original things themselves are left.
Building blocks.
Yes, are left untouched. So it makes copies. There is also another task which is changing the case. In this particular case, for example, if you've got text, you want to change it to lowercase, or you want to change it to uppercase, or you want to make titles. So if you want to change title case, basically you could say not title case. Let me say capitalization. Capitalize a string. If you want to capitalize a string, there is a method for this called title. Now, a string is not a simple data structure. It is actually an object. If it's an object, it means that strings come with specific functions called methods which can be used with these particular things, and that's basically what title is in this particular
What do
case.
you mean between data structure and object? What's the difference?
Data structures and objects are basically data structures store a collection of values. So once you create these data structures, they become objects. So once you have created a data structure, there are certain functions you can use with these particular data structures which you can't use with other things. For example, the length function can be used with any data structure. You can use length to find the size of any data structure. But in this particular case, as we're going to see, with our string book, which is principles of physics, what I want to do here is I want to make the first letter of each word a capital, which is what is capitalization in this particular case. And for me to do that, I'm going to use this function called a method. But for me to use a method, I need to first start out with the name of the string, which is the book, followed by a dot, then followed by the name of the function. You see this arrangement? The name of the string, then a dot, then followed by the name of the function. This is how you use a method. So I'll do that. So what I get is, now instead of getting this, your P, your O, and your have been capitalized, what I get is principles of physics. This is what I get with the method. This one here, this is a function. With a function, you start with the name of the function, then you give the function what to use. So in this particular case, print is a function, and I give it the string book. But for a method, you start with book, then you put a dot followed by the name of the function. There is this reverse on how these things are used. Is that clear? So when I speak about a function, I'm referring to something like this, where it's a function, then I give it something. When I speak about a method, I'm talking about something like this, where I start out with the thing I've created, this structure I've created, then I put a dot, then the name of the function. And these kind of functions are called methods. Now, if I print out book, in this particular case, you will notice that book has not been changed. But when I ran it with this particular function, this is what I got. So what happened? So what happens with methods is that methods will look at the structure you've given them, then they'll make a copy. So they don't modify the original thing. They will make a copy of what you have given them, then they will modify the copy and show you the result. Hence, the original value stored in book remains unchanged. So what you're seeing here is a modified copy of what's in book. Okay? So that's how you do that. So as you can see, this particular change you have done here is not permanent. So if you want this change to be permanent, then we'll have to store this modified value back in the variable book so that we can overwrite the original value which is there. So this bit here, book.title, this is what's going to give us this value. Then we want to, once that value is generated, we want to store it back in book. If you do that, then you make a printout of book, you see that now book has a new value, which is the modified one. So basically, this is how you make permanent changes to, this is one way, instead of you going and rewriting the principles of physics, since you can't modify anything like that, you can make your change like that. The other change you can do is you can capitalize everything. Now for you to capitalize everything, you have to use a method called upper, and that basically is short for uppercase. So if I print out book, so this is what I have, principles of physics, then I want to capitalize this, so I'll start with book, then dot, then the name of the method or function I'm using, which is upper. So what this is going to do is it's going to copy this. It's going to copy this value and modify the copy. The original value will remain unchanged. So when the copy is modified, what I get is this. I get principles of physics this way. If I print out book, again, you see that the actual value stored in book is still unchanged. So what was changed was actually the copy, and the modification to the copy is displayed to you. If you want to make the change permanent, of course, this bit is going to give us the modification to the copy. Then you can save the modification back into the variable book like that. And if you print out your book, now you have book having a value, principles of physics, all capitalized. If you want, yes?
Do those methods accept the arguments?
No. They don't accept arguments. These particular ones, they don't accept arguments. You just have the like that. If you want to change your thing to lowercase, there's also an appropriately named method called lower, which does just that. So in this particular case, I print out book, then I say book.lower. So it's going to copy this value, then make everything lowercase, and we get back to that. So this bit here is the copy which has been modified. If I print book, you see that book is still unmodified. So if I want to save the modification back into book, so I'll go book.lower. When the modification is done, then I save it back into book and I make a printout. I'm back to what I started with, principles of physics. So basically this is how kind of cleverly you can make modifications, but the only way to make it, this so-called modification in quotation marks, is not directly, but is to modify everything using these particular methods. Any questions? Okay. You can also add strings. You can combine strings, and this process of combining strings is what's referred to as string concatenation. Now, for you to combine strings, we actually use a plus sign in this particular case. So I'll create some new strings. The first one is going to be Isaac, first name, Isaac. Then I'll create another one, last name, Newton. Then I'll carry out an addition of these things. So the first one, this one contains Isaac. I do a plus, then I add a space. You can even add spaces. So I add a space in quotation marks because the space is a string. So it has to be in quotation marks. Then plus last name. Whatever I'm going to get from here, whatever comes out from here, I'm going to store it in a variable full name. So when I do that, okay, so basically, as you can see, the addition happens. You can add strings. What does the new value look like? This is what it looks like, Isaac Newton. So the first one, the first value Isaac, then the space we added, then Newton like that. So basically, this is how you do your string addition, just by using plus signs. So now that I've got Isaac Newton, I can print out. Remember, print can display multiple values. So in this particular case, I can display hello, then no, there's a mistake. Oh, okay, fine. No, it's fine. So hello plus full name and title. Now what I want here is this I to be capitalized and the N to be capitalized. As I'm using the title, then plus the exclamation mark at the end there. So if I do that, I get hello Isaac Newton in this particular case. This whole thing which I have here, this whole addition, like I did earlier with the Isaac Newton thing, I can store this whole string addition in another variable which I'm calling message here. So hello Isaac Newton message, then I do that, I save it in message, then I print out message. I'll get that. I'll get hello Isaac Newton. Okay, so you can add strings. Once you do the addition, you're happy with the addition, then you can save the addition in a variable, then use it for whatever things you want to use it for. Then white spaces like these are called white spaces. Tabs and end of line, these are all called white spaces. So basically, there you can add white spaces using special characters in to a string. So here I have got Python. I print out a string Python. Now I want to add a tab character before Python. Basically, a tab is 4 spaces. A collection of 4 spaces, that's what's referred to as a tab. For me to add a tab, I'll use this special character combination, a backslash and a T. So when I put a backslash here, followed by a T, the computer will know, or Python will know that I'm referring to a tab character. And if I do that, you see that there's this space which has been created here, and the Python is printed, the string is printed later there. So this is how you can add a tab. If you want to add double tabs, so you do the same combination, \t, \t, then the Python, if I do that, then I will have this. So I'll have created all this space there. You've seen up to there, that's one tab, then followed by another one. So I've added two tabs like that. I have this particular string which I want to print out here, languages, Python, C, JavaScript. So there are basically three things there, but these things need to be separated properly. So if I do a print out of this thing, this is what I get: languages, Python, C, JavaScript. But what I want to do is I want all these things on different lines. If I want them on different lines, then I'll use this combination, a backslash and the n. A backslash and the n is basically equivalent to you pressing the enter key on your keyboard. So after languages, there I want the computer Python to press the enter key for me. Then after Python here, I want another enter key. After C, I want another enter key. So if I do this, what I'm going to get is this, basically languages there, Python, C, and JavaScript, which is basically what makes more sense. If I want these things moved a bit, one tab, like that, then after each of the entering of the keys, I can insert a tab. So I enter the key \n, then I insert a tab immediately after that, and you can see that. So when I do that, what I end up having is these languages, then Python, C. That you can see before here, there is that tab which has been entered, there is that tab which has been entered, there is that tab which has been entered. These are white spaces. These are basically non-printing characters. So there is a bunch of them, non-printing characters, which you can use, and these are the common ones, and that's how you do that. Okay, you can have a string which contains white spaces, and maybe your task is to remove these white spaces because what you're interested in is only the printing part, the printing characters, and you don't want the non-printing characters. So basically, there's methods you can use. This arrow strip, this is basically a right strip. It means that remove the white space on the right of your string. Left strip, remove the white space on the left. Then there's a strip method which can remove at the same time white spaces on the left and the right, and you're going to see quickly how to do that. So here I create a string Python, and as you can see, it has got some spaces this side on the left. It also has got some spaces on the right, and I save this particular string in language. So I display language so that we can, if you want to see the actual quotation marks on your string, then you do not do a print. Just type the variable, then you can see that quotation marks there. So here in this particular case, I use double quotation marks, but Python itself thought I've overdone things, so it went to single quotation marks. So there is a way, if there is a bunch of combination of quotation marks, Python will figure out the best way to display things. So as you can see here, there's a space this side, on the left, there's a space on the right. If I want to remove the space on the right, which is this side, I'll say language.arrowStrip, right strip. If I do that, then you see the space on the right, this side, has been removed. But this is the method. Has it actually removed the space? It hasn't, because what it actually did was it made a copy. Methods look at what you've given them, they make a copy, then they modify the copy.
But the original remains.
Yes, because we can't modify the original, because strings are immutable. So basically what is being modified, all these methods which are trying to do fancy things, they make copies of the original and modify the copy and show you the result of the copy. The original one remains. Okay, then if you want to remove this particular bit this side, then you would use left strip like that. Do left strip, so you can see the left bit space gets removed. If you display language, it's still the same. So basically this is a way of doing this. I'm doing it like this so that I don't have to add any other space, because I have to also show how the strip works. For strip, it will strip the left and the right at the same time. So I say language dot strip. In this particular case, if you do that, you can see now you end up with Python. So the space on the left and the space on the right have been removed, and you end up with Python. And of course, that's what you have. So if you want a permanent change after the copy has been modified in the case of strip, which removes this side and this side, then the modified copy can be saved back into the particular variable and particular thing you have, like that. And now when you display language, now you can see that it has been permanently changed. So this is basically how you remove spaces on the left, on the right, or both. Any questions? Yes, Professor.
What happens if you have a space in the middle of, say, like what you have there is Python, but then you have a space in between P and
T and H.
P and H.
Yes.
I think there is a. So basically, in that particular case, I think there is something called split. So what split does? It's you can only remove spaces on the left and the right of your thing. So if somehow you wanted to do that, you'd probably have to break up things, split up your things, then like that. Yeah. Okay. Then formatting. Now formatting is similar to what happens in languages like C. Now with Python, the formatting is done a bit differently. Previously, it used to use C type formatting, but formatting is done differently. In place of you having your percent and everything else, Python uses curly brackets, and also you have to use this particular method format. So I'll quickly show how this particular bit works. So that's our Isaac with capital I. Then I print it out. That's what you have. Then this is our Newton with capital N. Then I print it out. So what I want to do is I want to display the message welcome Isaac Newton using a string format and whatever it is I have. So what I'm going to do is here, so I'll say print, then there is this collection here, this string here. It starts with quotation marks, it ends with quotation marks. So I start with welcome, then comma, then this are the so-called placeholders. This is where I want to place the values of first name and last name. Then followed by a dot, then the format function, then the variables I want to place in this particular placeholders here. So in this particular case, I want to place first name in this particular placeholder here. I want to place last name in that particular placeholder there. So if I do that, I get welcome Isaac Newton. So these things, once you do your formatting, they are not printed out, but they are replaced by the values of the corresponding variables which you have given to this particular format thing there. If you, yes.
Can it override?
What do you mean?
Can it override? Like, for example, if I put those curly brackets around M.
If you put what?
Can I, those curly brackets
Yes.
around M,
Mm-hmm.
can I override?
You want to? It's replacing these curly brackets with the value stored in these variables.
Okay. What I want, suppose I want to remove M. I want to override M.
M.
Okay. Yeah, M in the middle of welcome. Right in the
This
middle.
one. You can't, because it's a string. You can't modify strings. You can't modify strings. Okay, so here, so what are we saying? If I interchange last and first since the side, and if I run the same thing, I'll get a different result. I'll get welcome Newton Isaac. So basically what you're seeing here is the first variable is being placed there, the second value is being put there. This is basically how string formatting is done. So I create another variable, balance, 100, then I print it out. So now I want to say, welcome Isaac Newton, your account balance is 100 kwacha. Okay. We started late, so you should give me 5 minutes. Yeah, 5 minutes. Okay, so here. So with this, I have created a space for Isaac there, then Newton, then I've created a space here where I want to put the kwacha. So, actually it's supposed to be, oh, Newton Isaac, okay, fine, yeah. So welcome Newton Isaac, your account balance is 100 quarter. So basically that's how you do that bit there. So basically this is how you do your formatting thing. But you can be more specific about what you're trying to do. For example, how do you know to say, I want to put a string here. What should go here should be a number and stuff like that. That's where this particular bit called string representation comes in. So for characters, a single character, you use a C. For a string, you use S. For an integer, you use a D. For an exponential, you use an E or a capital X. For a number with a decimal point, you use F. If you want Python to decide for you whether to use exponential or just a float, you use G in that particular case. So how do we do this? So I specify here to say, with this combination with the colon and ace, I'm telling Python to say, I expect a string here. Anything else other than the string should not be allowed to go there. That's what I'm doing also here. So I expect a string here. So semicolon dot ace. Then here I'm telling Python I expect a number here. So I create these placeholders and I give Python instructions, say use a string here, use a string here, use a number here. If someone makes a mistake in that particular case, so first name is a string, last name is a string, balance is a number, so this particular bit is going to work. Say welcome Isaac Newton, your account balance is that. If I make a diff change here, where first is a string, second is a number, so balance will have to be put here. But I've told Python, say this placeholder is supposed to be used for a string. If I do that, then this one here is supposed to be for a number, but I've put a string there. If I do this, then I'm going to have problems. So it's going to tell me, say, okay, I was told that a string was supposed to come here, but someone is attempting to put a number there, so it's going to refuse. So basically that's how you start controlling what kind of information goes where with that. When it comes to setting precision, for example, how many decimal places, here I create a variable pi, then I print it out, then I check what kind of variable this is. It's a float, so it's f. So I can now say pi equals to, then I create this placeholder where I want to put the value for pi, then colon, then I put a dot here saying after the dot, after the decimal point, only use 2 decimal places, and what kind of value is supposed to come there? It's a float. Then I put dot format, then pi, and if I do that, I'm going to get my value of pi only to 2 decimal places. If I want 5 decimal places, then after the dot I put 5, then I'll get my value of pi to 5 decimal places. Then if I want 7, like that, I'll do that. So how can we use this? Well, if I want to display my 100 quarter, but I don't want to make Isaac Newton feel very bad, I can give him a dot and 2 zeros at the end here. So I can change the D here to F. Since it was an integer, I can change it to F like that and put 2 zeros. So you can say, okay, Mr. Newton, welcome. Your balance is 100 quarter with some 2 zeros there. So you can go out. Okay. You can also, lastly, you can state which one of these should come where. Remember, the indexing is, this one is the first one, this is the second one, this is the third value. And counting of positions, Python starts from 0. So you can state from the word go, as you are creating these spaces, where this should go. Should it come here or should it come here? You can explicitly state these things. And how do you do that? That's basically what we are trying to do here. So here I create 3 variables with 3 values at the same time. Basically, this is a fancy way of, if you have got some variables to create, you're going to do them at the same time. In this particular case, 6 is going to be stored in quantity. Banana is going to be stored in item. Then 9.5 is going to be stored in price. So if I do that, then I print out all these strings at the same time. So I have 6, banana, 9.5. So here, the first thing I'm doing is I am stating what should go where. What kind of, I create 3 placeholders. It's just the 3 lines left. I create 3 placeholders here. So I'm saying in the first one here, there should be a number. That's where the 6 is supposed to go. In the second one here, there should be a string. That's where I want to put the banana. In the third one here, there should be the price of the bananas. So that's quantity, item, and price. So if I do that, that's good. 6 banana costs 9.5 kwacha. Now, I can also have the same result if I say in this first value here, before the colon, I put the index of the item I want this side. The first one, I'm saying I want this first quantity put here. That's what the 0 is. It's the index for the first item. I want this second item put here. I want this last item, which has got index 2, put there. So I start with 0, then semicolon, how many decimal, whatever, it's stuff like that. So if I do this, you'll see that the result is going to be identical. 6 banana cost that. So it looks redundant, but the advantage is I no longer have to care about how I arrange these things. Once I do this, I no longer have to care about how I arrange this. I can say here, the second item with index 1, the second item is the quantity, which is this one here. I want second item here, and it should be an integer. Here, I want the last item with index 2, which is here, banana. Here, I want the first item in this list of things, which is the price. And if I do that there, you see that I get same thing, but different things. So basically, that's the end here.
All right, thank you very much. I hope before put up names.
Oh, I didn't. I'll put it in.
So I always tell my students, like first years, I say, do you know how to swim? I ask them, no, don't know. Okay, how to swim? You do like this. Use Newton's third law of motion.